today is I want to go through what's called turning point form, or sketching parabolas in turning point form. I thought it was important to just get as an idea, practicing on looking or remembering the terminology for our transformations, but also being able to identify all the necessary points for a graph. So in each of these, what I've done is I've got the original graph, which is y equals x squared. So if you flick through all the pages, you'll notice that basically that's copied in each one. And what I've done is I've put a graph on the right. The idea is that we're going to work on these together and we're going to identify all the important points necessary. So, start with this friend. So, that was the original graph. And then on the new graph, which we can see here, something has happened to it. So the original one, we can see there, is sitting right on the x-axis. The new one is sitting underneath it. Would anyone be game enough to be able to tell me what would we define the transformation to be? It hasn't been stretched so much, but I can see how you can see that. It looks like it's been stretched. Miss Kay?
Has it been translated?
It has. It has been translated, and could you tell me how much it's been translated by?
2.
2? Yep.
Is it 2? It's minus 2.
Yeah, so 2, what we say is by 2 units down. And that's a totes legit way of writing it at year 12. It's been, some fancy pants textbooks like to say something like, it's been translated parallel to the y-axis by units of -2. Shut up. It's been translated down 2 units. It's fine. So there we go. It's been translated is of course our meaning for moved. That's Matt's way of doing that. So the question is, I need a set of coordinates for the turning point. What would be, put your hand up if you can tell me, what would be the coordinates, what would I write for the turning point of our new friend? Mr. Spaulding.
0, -2.
It is 0, -2.
Wait, how do you notice the new one? Oh, the last one hasn't been translated yet.
Yeah.
Sorry, it hasn't made it.
That's okay. All of these are in reference to the new one. So you'll see this for a reference to the new one. Now, the next one says maximum or minimum. What that means is the turning point, would we call it a maximum figure or a minimum figure? So what do you reckon, using sheer logic, would that be a maximum or minimum?
Maximum.
Funny enough, why would you classify as a maximum?
I was doing the question.
Yeah, you're doing the questions, and what was the question saying?
It was like the negative numbers were maximum and positive numbers were minimum.
Okay, well, I see, exactly, yep. So, negative, when there's a negative in front of the x squared, you'll get a maximum,
Yeah.
Yep. This is actually what's called a minimum, and the reason is, it's the lowest point of the graph. So, if you see the word maximum, it's the highest point, and the minimum is the lowest. So, this has a minimum. Why, even though why would I say that graph doesn't have a maximum? Why would I say that, do you think, Mr. Schwab?
Because the plane's infinite?
Yeah, basically because it goes on forever. That's why I say it doesn't have a maximum. Because it goes on and on and on forever, kind of like me on a period 4 on Friday, that's why it's only got a minimum.
So that means no graph ever has a maximum.
Unless it's been flipped upside down.
Yeah.
I think we did we do one of the graphs that's been flipped upside down?
Yeah.
Last lesson? Yeah. That one has a maximum and wouldn't have a minimum. So the new equation looks like this. It's just x squared minus 2. You remember that last lesson we were looking at graphs that had little brackety duties and that moved it left or right. When there's no brackety duties, of course that being the technical term, it's actually moving it up or down. Okay? So, now, intercepts. In order to find a y-intercept, what would I normally do? If you think back to linear graphs and things like that, if I wanted to find where the y-intercept is, what do I do?
Rise over run or something, isn't it?
That's the gradient, rise over run. What would I do, Mr. Schwab? Yeah, so, exactly right. And some of you who were unfortunate enough to be stuck with me last year would know that I was very stringent when it comes to writing on y-intercept. It should always be, or x-intercept, it should always be in coordinate form, because that is the required form at year 12. Sorry? Well, some people might write y-intercept equals -2, which, yeah, I can see what you mean, but it's so it's
It's just -2.
yeah, it wouldn't make sense. So that's why we always make it a coordinate form, and it depends on which textbook you listen to. So y-intercept, we just look at the graph, and we would calculate that. Now, unfortunately. Now, if you look at the graph and you're finding the x-intercepts, it might be a little bit harder because you'll see that the x-intercepts are somewhere in between 1 and 2 and between -1 and -2. So if we didn't have a pretty graph and we're trying to find the x-intercepts in the first place, what do we normally do to find x-intercepts? Substitute what? That's correct. We let y equals 0 and we solve. So 0 is equal to x squared minus 2. And then what we can do is we add 2 to both sides. And we'll get, hope people can see my green there. I'm just adding 2 to both sides. Get 2 is equal to x squared. What's the opposite of squared? Square root, yeah. So we've got to square root both sides. And then we get the square root of 2. Now you'll notice there that I've only got one answer, but I can quite clearly see 2 possible x-intercepts. So what do I need to have included? Yes?
The plus or minus sign.
Exactly right. The little plus or minus sign, because remember, if I had -2 and I squared that, that would also equal +4, as much as 2 squared would be +4. So whenever we do a square root, as you can see here, we need to have this little plus or minus sign. So I know that if I had 2 negatives multiplied together would be a positive, and 2 positives multiplied together would be positive. So now I can tell you that my x-intercepts are at -square root 2, 0 and square root of 2, 0. There they are. And if you were curious how to do that in a calculator, of course, then you would just use the solve function, and then you would have x squared minus 2 equals 0, comma, x. And I would also make sure it said standard on your calculator. Okay?
Climbed up and fell.
Yeah, well, exactly right. So this has more than one transformation. Anyone brave enough? Miss Beth.
And the translation up by 6 get reflected.
Oh, you are so right. It has been reflected in the x-axis and translated up by 6 units. And what would be the turning point of this, friend? Oh, well, spoiler alert of the next equation. That is correct. That's the new equation. What would be the turning point of this, friend? Yes, Mr. Austin.
0 and 6.
0, 6, yeah. Is this a maximum or a minimum? Maximum. Okay. So, in this particular case, we can see that there is a y-intercept like all the other ones right at the turning point. So the y-intercept is at 0, 6. But of course the x-intercepts, that might be a little bit hard. It's somewhere between -3 and -2, and somewhere between 2 and 3. So we'll need to let y equals 0. So we'll get 0 is equal to -x squared plus 6. -6 is equal to -x squared. 6 is equal to x squared. So x is equal to plus or minus the square root of 6. And so therefore the x-intercepts, one's at -√6 and one's at +√6. 0. Next one, what's the transformation? Put your hand up if you've got a transformation for this one. Mr. Austin, what is the transformation?
It has been translated 5 to the right.
Yep. It has been indeed translated 5 units to the right. So the turning point, where is the turning point for this, friend? Oh yes, Ms. Hartwick.
5, 0.
It is indeed 5, 0. So hooray, that means you also found the x-intercept, which is handy.
Oh, yay!
There we go. Is it a maximum or a minimum? Minimum. So this case is a new equation, which would be referenced to yesterday's notes. Could anyone have a guess what it might look like? Mr. Austin, what do you reckon?
Y equals 5 squared.
Not so much y equals 5 squared. Anyone remember from the last lessons? Those Mr. Sporting, what do you reckon? It has brackets.
It's x
Now it's got to be either.
minus 5.
It is indeed x minus 5 squared. And it's moved it on to the right. Now, and now we just need to go and find the y-intercept. Unfortunately, my graph, I've rather inconveniently cut off the graph before it hit the y-axis like a jerk face that I am. So we're going to need to go and work this out by pen and paper. So for y-intercept, we make x equals 0. So this would become y equals 0 minus 5 squared. Negative 5 squared is what? 25. So therefore the y-intercept is at 0, 25. Now, this one. Again, it's got multiple transformations in this one. Anyone keen to tell me what's happened with this one? I heard several things there. What's one of the translations, Mr. Musgrove? It's gone up by 4, and then what? Yep.
3 to the right.
It's 3 to the right, yep. To the right by 3. So the new turning point, what is the... Miss Price, would you be able to perhaps tell me where the new turning point is? It is 3, 4. It could have its own club. Alrighty, so is it a max or min? Min. Now, here's the challenge though. What would this equation be, do you reckon? Miss Kay, what do you reckon?
No. Y equals x minus 3 squared plus 4. Squared brackets plus, yeah.
Boom. So yeah, the brackets tell us that it's moved, and I was about to turn into an upside down graph there just a moment. X minus 3, it's moved to the right by 3, and it's gone up by 4.
Could you do it the other? Yes.
No.
No.
Oh good, yes, no, that's
Could you
still...
do it the other way around?
What, 4 plus brackets x minus 3 squared? Yes.
Because x can't be net. Okay, that works. Yeah. Yep.
That works for you, is it? Is it right?
Yes.
Is there x-intercepts? No. Is the graph clear enough to find out what the y-intercept is? 13, yep.
Wait, shouldn't it be minus 4?
No, because minus 4 goes down.
No. Yeah.
No, it's plus 4. Look at your previous examples when the graph has gone up.
It's only one. You just have to argue.
It went plus and it went up.
No, that was in brackets. Plus in the brackets moves it left.
I get you.
Yep. This one is slightly different. I would start with the translations for a start, so you could, because there's also another one that's a little bit different. You'll notice there I've got a faint outline of the original graph on this one. Can someone please tell me what the translations are? It has become skinnier, so there's another transformation, but what's the translations? Okay, well, where's it been moved?
Down y by 4.
Yep.
And right along x by 5.
Okay, so it's translated down 4 units. Right by 5 units. And luckily, people have picked up that it's been dilated. So dilated is our word for stretched. Okay. Now, there's a couple of ways that we could go about guessing or figuring it out. Would anyone like to guess how much they reckon it's been stretched by? By what factor?
No.
By enough. Yeah.
But not too much. Not too much.
It's half.
An amount.
Okay.
Yeah.
I say now, if it had been dilated by half, it actually would have become wider. But you are so close.
Negative a half.
Not so much negative a half, because the negative would mean it's flipped upside down. It's been doubled. So this is dilated by a factor of 2.
But how can you tell?
Okay.
Did we go through it? Did we go through this?
Okay, so one, it's skinnier by, it's about half the width it was before. I can do an elaborate proof, which we'll talk about a little bit later. That will tell you how you can. I just wanted to put this up so you can see it. At year 10 level, as long as you can see that it's been dilated, that's been fine. So that you can, essentially reason why from a year 10 level you would need to sketch a graph and you'd be able to show that your graph should be skinnier than the other one.
Is there a thing in the textbook that requires us to figure out the factor of dilation?
No. Not for 9.4 anyway. It's actually not that hard to find out, so we'll sort this out later. I think you'll find it's year 11 standard anyway. What's the turning point?
5, negative 4.
5, negative 4. Max or min?
Min.
And this graph has got a 2 at the front, then x minus 5 squared minus 4. So when it's been dilated, there's a big old number at the front.
So, when you reflect it or dilate it, it's always before the bracket.
That's spot on, yeah. Reflections and dilations work very well together. They'd always go at the front. So, at least dilations by a factor of 2, and I should write from the x-axis, because that's where it's been stretched from. So it's been dilated by a factor of 2 from the x-axis. There is also such a thing as dilation from the y-axis. My hand gestures help. Stop teasing me, bullies. We'll need to work out both the y-intercept and the x-intercept. Five squared or negative 5 squared? What's negative 5 squared? 25 times 2? Take away 4? So that's where the y-intercept is. The x-intercept x-intercepts when y equals 0. So that becomes 4 is equal to 2. How does what work, sorry? Oh, good, okay. Then divide both sides by 2. And then square root of 2 plus or minus is equal to x minus 5. And then 5 plus or minus square root of 2 is equal to x. So therefore the two intercepts
Every 20 seconds I just go around and just